So perhaps I should show this one here first. So I'm kind of new to this. I'm learning. So I talked to this guy last night. So we know that thermodynamics in thermodynamics the hot temperature will equalize and it will the heat will flow towards the cold. Okay, this is what we learn. But the reality, Matthew, is this thing right here. Okay, the molecules will always fight to be above of the cold one. It will like escalate. Okay, so based on this, let's go ahead and start this video. So there's no audio. We're just gonna watch and talk about it. Okay.
Okay, let's take a look.
So that's definition. Thermodynamics is the study of the relations between heat, work, temperature, and energy. The laws of thermodynamics describe how the energy in a system changes and whether the system can perform useful work. So it's similar to this thing here. The guys are escalating, to a higher because the people have energy, so they can escalate and go higher. This is how the molecules work. The heated uh, molecules, since they have more energy, they will escalate to the top and leave the cold molecules on the bottom. So just
Even
like you
air,
see,
right? Like
yeah,
even
even
air
air.
itself, there will be different, like not just oxygen, but there will be other types of gases in the air also, and it'll
Exactly,
stack on top of each other.
exactly. So this is
Yep,
him
and
performing this experiment, Matthew. You see the water there is, he has a 132 Fahrenheit, pretty hot. He has the cold water there, 12 degrees Celsius, 53 Fahrenheit. And that ball is just room temperature. Okay, just room temperature, 37 degrees, 99, Fahrenheit.
nice. And I
So,
appreciate seeing the Fahrenheit also. Like that's cool.
yeah, 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 yeah. Yeah,
Like
I
seeing
added
the
that
like the
stuff, man.
relation.
Yeah,
Cool, nice touch.
so what he did, he got a sample of the water, the room temperature water. So what's he gonna do? He's gonna place that inside both of them one at a time. So what do you think is gonna happen, Matthew, if when he places that vial with room temperature water, let's say inside that the cold water? What do you think is gonna happen?
I think there's going to be some type of reaction with the neutral water when it's exposed to either the hot or the cold.
Do you think it's
Like,
gonna
cause
float
that's
or sink?
I'm not really sure, but I know like if it was really hot and really cold, it would change the water itself from its
Yeah, the
state of
vial would
matter.
adapt, right?
But
Would
but
adapt.
but but this looks like an interesting experiment. I'd like to see what they're doing. Like
Okay,
I'd like to
so you
see what
have
they're.
okay, that's the hot water right there. Okay, the temperature is higher than the temperature in the vial. Okay, remember the vial is room temperature. On the left side, he has cold water. Now he's going to, let me see which one he's going to do it first. I think he's going to place in both of them. Okay, all right, there it is. He placed the room temperature vial inside the hot water. So why did it sink? Why do you think it sank?
Oh, because of the temperature,
The temperature. So the
right? When it
hot
was.
water, the molecules will push the one that's colder down. Okay,
Yeah.
has nothing to do with the gravity. Absolutely nothing to do with gravity. It's just the molecules, the hot molecules are pushing. You know. Now look at what he's gonna do
Oh,
now.
okay.
What do you think is gonna happen now? Do you think it's gonna sink the vial?
Well, I was thinking about like hot air rises and cold air goes down. So I'm trying to think how that would affect the neutral water. Like if it was in cold water, it might rise up because it's hotter, right?
Right.
I'm I'm
So
I'm not sure. I'd like to see what they're doing. And that does seem like an interesting experiment.
oh yeah, look at what's going to happen. The vial, since the temperature in the vial is hotter than the cold water, it's not going to sink all the way to the bottom. See what I mean? This water on top here, it's warmer, it's pushing the vial down, but the vial has a temperature higher than this water, so it's not going to sink.
Yeah,
Understand?
that's pretty
Because
cool. Yeah, I get
yeah,
it. That's pretty cool. Like it
yeah,
wants to
because
be at a certain level. It wants to seek out a certain equilibrium state within the two temperatures of water, and
exactly,
that's what the
exactly,
experiment was showing. That's very
exactly.
interesting.
Yeah, and now he's gonna add a dye to identify. It's better to identify the hot water and the cold water. Okay, so he's placing a dye there in the hot water, 127 degrees Fahrenheit, about 53 degrees Celsius. So that's the hot water right there, orange color, yellowish orange, and the blue, of course, for the cold water. So that shows, man, this has a lot of implications, Matthew. And I will explain as we go on with these experiments right there. So, guys, in the chat, I'm not checking the chat right now. We're just going to cover this. I'll talk to you guys in a little bit. So, he's going to place the vial again. Remember, the vial has, I think, I forgot if he took the temperature in the vial. Let me see.
What was it? It was something like 80, right? 85 or something
Yeah,
like
yeah.
that. I can't remember
So,
offhand, but it was like in the
okay.
middle somewhere.
I think let me see what's going to happen. If the vial has a temperature colder than the blue light water, it means it's going to sink. Let's see, I forgot. We were talking. Okay, the same thing there. Let me see if it's going to sink. No. So the vial has a temperature in between the top and the bottom. So that's why it's in the middle. Okay?
Yeah, and
So it has
it's
not
cool that that the water has the color too to show that, like, to show what's being expressed here. Like the cold water will stay lower and the
you're
hot
right.
water will stay above it.
Exactly. And since the vial has a temperature in between, it's not going to sink. So where is gravity right there? Gravity cannot, gravity is easily overcome by the temperature, by the heat, by energy.
No, there is no gravity. There is no gravity. That doesn't exist.
It doesn't exist at all. All right. So interesting
Yeah,
because he's
there's
going to,
down. Yeah, there's the
yeah,
down, right? But there's no gravity.
exactly. And he's going to repeat this by changing the temperature in the vial. So you're going to see. So let's now apply energy heat to the vial and see what happens. So the vial, the temperature will be hotter than both containers, So now
It's gonna
you see
rise.
there?
It's gonna go
Yeah,
up. I think
it's
it's
going to
gonna go
rise.
up once it.
That's what's going to happen. So you have the cold water about the same temperature, 53 Fahrenheit. The hot water is getting a little bit less hotter because took him several hours to conduct that experiment.
Yeah, that's cool.
Yeah, yeah. So
I've
look, the
never
vial
seen that
now
before.
has a temperature of 129 degrees Fahrenheit. Okay. So again, he's gonna add the dye. Okay, cold water right there. Man, they are spending time and money. They are buying those equipments. They're not buying cheap equipments. Like he was showing me the price. One is small scale, like $300. You know,
For
he
what?
showed me he bought like 3 vacuum chambers. He showed me last night. So you see there, the vial, remember,
Oh,
has a
this is your
temperature of
friend, right? Like
yeah,
this
yeah,
guy
yeah.
is your buddy. Okay.
Yes, yes, yes. So now you see the vial. The temperature in the vial is higher than the temperature in the hot water. So what happens is it's going to float because the energy, according to thermodynamics, the molecules will fight to stay above. It will push down the molecules that are colder. Okay? So it's
Yeah.
floating there and it's going to float again because the temperature there is higher. Isn't that cool?
Yeah, that is pretty
Hmm.
cool.
So the temperature in the vial is 129 degrees Fahrenheit. So it's fighting to stay above. It's going to push down the molecules, the colder molecules. So where is gravity there again? Once again, a little bit of energy and heat change the whole game.
Yeah. Yeah, see, it's there's no gravity. It's non-existent.
So now let's remove heat or energy from the vial and see what happens. So he's going to do the same thing, and he's going to have cold water inside the vial.
Nice.
And of
That,
course, it's gonna go down.
yeah, because it's cold, and it'll want to seek the lowest level because it's cold,
Yeah, yeah.
or
And
because
the
it'll be colder
warmer,
than what is around it.
yeah, the hot molecules will push it down. Okay, it's gonna push it down. So
And
pretty
this is
cool.
also very thorough. Like I like that there's the different demonstrations are being shown, like in the
Exactly.
medium range, and then when it's
Yeah,
really hot, and then now this one it'll be kind of cold, I guess.
yeah, yeah. The vial. See, it's 55
It's a good way
degree
to do
Fahrenheit. It's gonna be colder than both containers. Okay.
Yeah, that's cool.
So I did it, and I added the temperature in Fahrenheit because for the people in the US, it's better to understand what's going on here. He's going to apply the dye again, which will help us to identify the samples. So he's got like the hot 127 Fahrenheit. The That's not room temperature. That's kind of cold, 66 Fahrenheit. But remember, the vial is like down to 50 something, so it's much colder.
Okay. Yeah, so it'll seek the to go to the very bottom.
Yeah, yes. So that's what he's gonna do there.
That's cool.
Place. Yeah, man. I mean, they are making. Now I'm gonna tell you what else they're doing, he kind of briefed me last night, and so he didn't add the dye. I think he ran out, but that's the hot water, 127 Fahrenheit. Of course, he did sink because the molecules, the hot energized molecules, will push it down. Okay, has nothing to do with
Yeah.
gravity. And now, since the vial is colder than the blue water, which is cold, it's gonna go all the way to the bottom one more time. So this has nothing to do with gravity. It's just like the heated molecules, which is more energized, will push the vial down. It's not gravity, you know?
So if somehow there could be a device within that little that thing to make it hot, then it would just rise easily.
E- Exactly. If you
Like that would
apply
be really
energy,
that'd be weird technology. Like and then it would let it cool down and it goes down.
see there?
Like there, yeah,
It's all the way
they
from the
see it.
bottom because now let me tell you what's going on, Matthew. They are doing a lot of
Okay.
experiments and they collected air from up higher. They released some balloon, high temperature balloon, I mean high altitude balloons. They collected air. And the thing is, uh, so that's the video. Thank you, Alain Horizontes Prime. Shout out to you. Let me go back here and
Nice.
remove this. So what's going on, Matthew?
Nice.
They collected some samples of air, and we all think that the denser air, heavier air is below, and the lighter air is on top. But also, the problem is the density is the same. It's just like the air on top is more heated, and it's pushing down the colder molecules. Okay, the consistency is about the same. That's what they found out. It's the same. The air on top, it's not that is less dense. It's just like it's more heated. Has more energy, And just like we saw in the experiment right now, it's pushing down the molecule, the colder molecules. Isn't that interesting?
Yeah, that is it's pretty cool. And it's interesting what happens when it's hot, like when the sun comes through and then as it goes away, how that same air is charged. And I
Right.
see it often here where I live, how the sky looks purple and pink and orange. It's like it's usually before sunrise, and then a little bit it after that, and then before sunset, and a little bit after that. And it's just
I
very interesting. And then the air too, how when it heats up, it does move a lot. Like the wind increases and everything, and when it's cold too, that's an
yeah,
interesting
man.
presentation. I like that one.
So he is in the house, but I think he's in church right now. And Andre is not really fluent in English. I asked him to come over and talk more about it. He told me he needs to, you know, get more fluent in English. So he'll be. But the other thing, like we have, like in Brazil, when they play soccer, for example, they play like regional championships, like Brazil plays against Peru or Ecuador. So when the Brazilian team goes to play in Bolivia, Bolivia is really high in temperature, and I mean not temperature, altitude. It's like I don't know, 3,000 miles, meters above sea level, 2,000 meters. I don't remember. So the Brazilian soccer players always have a good hard time playing there. They always lose because they can't breathe, you know, because of the temperature. But the people who are there, they can because they are used to. All right. So according to Andrea, and we were talking last night, man, it's not that we have less oxygen on top. It's just like we are not used to. You can adapt. You actually, if it was possible, just like think about it, Matthew, when they were building the Tower of Babel, they reached certain heights, okay? And they were able to breathe and work because they're working with bricks, you know? And they were breathing. As you go up, you can adapt if you go slowly, you know? Yeah, of
Or
course, if you go in one,
they could have technology too in the past that
yeah, yeah,
oxygen that would have been easy for them if they could
yeah,
have done the things that they left behind. Simple things would have been very easy.
right. But he was telling me like some people, like when you go and you climb Mount Everest, some people need to have oxygen masks and stuff. But some people, because they have been going there so for so many times, they are adapting. Some people are able
Yeah,
to stay on top of the Everest without any oxygen masks.
yeah. And you know what that reminds me of? The people that do deep diving for pearls. Like it's
Right, right.
like the people that live in those islands, they could be down there for,
Caribbean.
well, not just there, but also like maybe in Asia too. Like the people that could swim down for like 5 minutes, 6 minutes, no problem. That's, and
Okay.
then for other people, it might be very difficult to even hold their breath for 1 minute. Like that would be kind of difficult.
Yeah, man, I can't stay like a minute underwater. And these people stay like I have on my book a lady. She had back in the 90s the world record. She spent 6 minutes, man, underwater, and her record has been beaten already. So I can't imagine someone staying like 5 minutes underwater. And she dove for clams and seashells and stuff like that. She grew up in the Caribbean and she did it this since
Yeah,
she was a kid, and she thought, well, that's what I've been doing since I was a kid. So you can adapt. So if it was possible, Matthew, for us to slowly climb, not in 1 hour, 2 hours like they do, but it's possible to breathe up there, if we could do this, slowly. Very interesting, man. I really, I'm gonna bring more of this stuff
well, even
because
diving too. Like I don't know too much about scuba diving, but it's the same kind of thing. You don't want to go down too quickly because something about the blood has to change as you go down. Have you heard about
Exactly.
that? Or I've
Yeah,
never
yeah,
done
yeah,
it, but
yeah. I did
they
the
don't want
same
to just
thing
go
when
straight down.
they are climbing up, like the guys in submarine. I think they got to do it really slowly. They can't just climb up fast. Got to go really slowly, you
Yeah,
know.
they'll die. Something happens with the blood, like they'll die. If they go straight down, it's too much of a stress on the body. That
Exactly.
makes
Well,
sense.
shout out to whistleblower in Texas. He just told me La Paz is 3,650 meters high, so about 2,000 miles, man.
Nice.
A little bit more, 2,200 miles long. Imagine you used to play soccer like in São Paulo, sea level, and then you go play. And that's why when you watch, man, I watch those games, Brazilian soccer players, they just fall on the field. You know, they can't run for 90 minutes, 45 minutes. They just can't because it's too fast, you know. They can't make that change, you know.
Yeah, of
So,
course. And then, I mean, they don't live there, so I mean, they probably don't get a lot of chance to train or what is it called, acclimate to the altitude.
yeah, yeah,
So
yeah,
yeah,
you have to.
they would just suffer.
Don't waste any more time. Visit the links above now and order my book 16 Emergency Landings Proving Flat Earth. Visit my online store now and order the new enhanced Gleason's Flat Earth map. This map used to be in every school and library in the nation before NASA was created in 1958, when the maps were ordered removed. Have your Gleason's map hanging on the wall in your house where no government can take it down. Here you see it hanging on a wall in the house of the late Charles K. Johnson. Here is a quote from the book 1984 by George Orwell. Every record has been destroyed or falsified, every book rewritten, every picture has been repainted, every statue and street building has been renamed, every date has been altered, and the process is continuing day by day and minute by minute. History has stopped. Order your map now.